Good afternoon or good morning, depending on where you're listening from today, and welcome to TME Presents Applying the Expeditionary Mindset to the Water Industry. You've read the article, now learn the rest of the story. I'm Daniel Wheatley, the Associate Editor for the Military Engineer, and it's my pleasure to welcome you all here today. Before we get started, though, I'd like to go over a few items so you know how to best participate in today's event. All the attendees are in a listen-only mode for the presentation. You can use the chat pane to chat with your fellow attendees. Everybody, let's try that now by typing in your name and your current job position. You can submit questions for the presenters at any time by using the questions pane of the chat pane. We'll collect these and address as many as we can during the Q&A session at the end of the presentation. If you see a question that you'd like answered, click the thumbs up icon next to it to upvote it so it rises to the top of the list. Please also submit any technical issues you may be encountering here as well. You'll be able to download the slide deck and your PDH certificate from the Handouts tab once we begin the Q&A session. Originally published in the July-August 2021 issue of TME, Applying the Expeditionary Mindset to the Water Industry discussed how the water industry must develop a more extensive expeditionary risk management mindset in order to prevent disruptions such as the one caused by the February 2021 Texas winter storm Yuri. Incorporating insights gathered from expeditionary risk management programs at the National Aeronautics and Space Administration and the U.S. Air Force can provide a path to address high-impact vulnerabilities in this critical industry. I would now like to introduce the authors and today's featured speakers. Major Justin Baird with Texas A&M University, retired Lieutenant Colonel Dr. Patrick Suermann, Associate Professor, also with Texas A&M, and Dr. Chuck Wolfe, Principal and Vice President, Freese and Nichols. With that, I'll turn it over to our three featured speakers.
Hello, good afternoon, everyone. Thank you for joining us today. We look forward to speaking with you over the next hour. We'd like to thank TME for publishing our article and for highlighting this article in the monthly webinar series. Today, as we talk through Winter Storm Yuri that devastated Texas almost a year ago this week, and we start talking about systems thinking and organization structured around operating primarily in an expeditionary environment, I would really like to focus on having a different mindset when it comes to industry application, whether it be the water industry or really any industry where high impact risks need to be addressed. This expeditionary mindset is one that I believe many of us can relate to, being in the military, retired military, or associated with an industry where high impact risks can have very costly effects. For our team, there's myself, Major Justin Baird with the United States Air Force and the Medical Service Corps, and a member of MSAINT. Dr. Patrick Suermann with Texas A&M University, Interim Dean of the College of Architecture, and then Dr. Chuck Wolfe. So if you would have asked me 20 years ago where I would be today and what I would be doing, I would never have guessed. My professional career really started at Virginia Tech back in 2004, and as a senior within the Corps Cadets. There I learned of my current position and role within the Air Force. And so from that point, I realized what I wanted to do, but little did I know that that process would take, that hiring process would take 2 years. And with graduating during the major recession in construction and across the country, that led me to really start at lower levels in construction as a laborer for a fireproofing contractor. Soon after, I took a direct commission into the Air Force in 2011 as a health facilities officer and leading healthcare construction for the United States Air Force. Now we're merging into the Defense Health Agency. And that led me to the opportunity to lead several of the largest projects within the Air Force at Joint Base San Antonio, Lackland, one being the new Wilford Hall Ambulatory Surgical Center replacement project, as well as the new Reed Clinic for all of the basic trainees processing through Lackland, with a total portfolio of approximately $500 million. But really at the center of it all has been my family, wife Christine, and 3 children, Matthew, Brian, and Hannah. It's been through their love and support that I've had and been able to accomplish all of the success and adventures that I've been on. Now I'll turn it over to Dr. Patrick Suermann.
Thanks, Justin. I'm excited to be here with you today. I'm looking through the poll here and seeing we've got New York and Georgia, Arizona, Ohio, even some international folks here from the United Kingdom and in Spain. So this is exciting to talk to you about, talk with you today. That's one of the things that I've been excited about is similar to Justin, my family really is how I define myself. But because my family's so great, I've been able to go around the world and been deployed to Afghanistan and Saudi Arabia. Did a lot of work in Guam, and then finished out my career as a commander in Greenland, and also was a professor at the Air Force Academy a couple times before becoming the Department Head of Construction Science at A&M and now the interim dean of architecture. But that's the thing that I would say is it's the relationships that you have as people, and you're always going to have the emotions that go along with those relationships. But that's one of the things about a relatively dry topic. But I hope that we provide some resources that a lot of military folks may not have been aware of previously. And then also have you look through it at a new lens, as well as some tools that we recommend be consulted with before looking at the stochastic infrastructure industry that Dr. Chuck Wolfe is most familiar with. And so with that, I look forward to handing it over to Chuck to introduce himself.
So thank you, guys. My name is Chuck Wolfe. So I have 2 roles. As mentioned earlier, I'm a principal and vice president with Freese and Nichols. I'm also a professor of practice in the Civil and Environmental Engineering Department at Texas A&M University. So over my career, I've had the benefit of working in different places around the country. Did work in Los Angeles, did work in Phoenix, including up north, Midwest area as well. But Winter Storm Yuri was one of these events that sort of brought a lot of things together, both in my professional life and my academic life. What I work on in academia is really focusing on resiliency of communities and how we can improve communities' responses to disasters. So Winter Storm Yuri sort of brought a lot of that stuff together with what we do as a firm in the water industry. So I'll try to bring some of that to you guys a little bit later in the presentation. But first, I'm going to launch us into a bit of an overview of Winter Storm Yuri and the impacts that came from the event. So certainly those of you that are calling in from Texas know exactly what happened this week last year. Winter Storm Yuri was sort of a Valentine's Day, February 15th present, where we plunged the state into a frozen state. So we had 16 million Texans that were impacted. 2,000 of the 7,000 water systems in Texas were disrupted and had boil water notices or some other type of impact. What really sort of happened was this cascading series of failures in the system. Those of you that don't know a lot about Texas, maybe Texas has its own power grid. It's completely separated from the rest of the United States, and it's pretty robust in its general design, but it really wasn't designed against this kind of a freeze, this kind of a situation. So we sort of had a cascading series of different issues that piled up that created conditions that ultimately impacted water systems, wastewater systems, and other public health systems as well. So the impacts from the event, the cost of the event was pretty significant. Total economic loss is estimated around $130 billion. Agricultural loss is $600 million just by itself. Significant residential and commercial owner losses as well on a specific owner basis. So we had this situation because of the way that electricity sold around the state. You have electricity prices that really spiked during the event. I've got a very good friend of mine who runs one of the refineries, and they actually got their cogen systems back up and running and didn't turn the refinery on. They just sold power back to the grid because the price of electrical power generation went up so high as these different systems started to fail around the state. So it had significant cost, significant impact. It also had a significant impact on life. So it's estimated that 246 people died as a direct result of Winter Storm Yuri. I've seen numbers of up to 600 or 700 that would be secondary impacts to the because of the event. Overall, there were 14 million Texans that were under boil water notices, 4.5 million Texans that lost power. And one of the amazing things about it is this data point has moved around. I've seen it jump around a little bit, but we were about 277 seconds short of a complete grid collapse before the regulatory control agency sort of stepped in and said, we're going to start doing rolling brownouts, everything else. So this is an event that had a significant impact on the electrical system. And of course, electrical system drives pretty much everything else when you have a developed economy. So some of the things we took away from the story, from the storm itself that played into the article. One is this: how can we use an expeditionary experience? And this is a great application of where you need to think about things the way you think about it if you're truly in an expeditionary setting. The criticality of consistent water supply was certainly evident to all of the folks that were impacted, but also the criticality of the supply chain, not the supply chain we've been talking about for the rest of 2021 and 2022, but the supply chain that feeds these operating systems, and then sort of how that fits into a systematic logic for the water industry. So we're going to talk through each of those components for the rest of this webinar. So I'll hand it back over to Pat.
Thanks, Chuck. Before we do that again, I'm glad that Dan is launching the poll here. And so we want to make sure that we ask you about your familiarity with these types of concepts, because some of the things I'm going to go over today are definitely introductory. I'm going to describe a 286-page NASA manual to you. So obviously, I don't think we have the rest of the day today. So I want people to hopefully fill out your poll there. And I always like to have some student participation. I also saw there's a lot of senior folks on here, which is great. I love the opportunities that SAME provides for mentoring for young folks, and then also for those young folks to mentor our senior and retired folks. But overall, it's looking like the poll results are coming in here. And it looks like most people say they have about an average level of knowledge. It's almost a perfect normal distribution here on a if this was a histogram or a pyramid. We've got second answer is some familiarity, but not much. And so I think that I will talk about some risk management and some systems engineering thinking for you. And then Dr. Chuck Wolfe can also definitely talk more about the water systems that you may have less experience in. And take your mind to some primetime TV for a second. And if you think about Shark Tank, a lot of times people on Shark Tank, if they're pitching a project or a product, they'll say, well, imagine that we're the Airbnb of this, or we are the Gatorade of that, or something like that. And that's one of the things that I find is successful, is that a lot of times we have so many DoD instructions in the military, or state regulatory agency might have the things that they look at. Is I find it's helpful to look at parallel industries and who is probably more skilled than looking at risk than the National Aeronautics and Space Administration. And so that was one of the things that when Major Baird and I were talking about while he was working through his Master's of Science of Construction Management, how could we apply some NASA intelligence into different processes that we do? And just as Chuck said, it was very timely because I was working with Justin at this time last year before he returned back into normal active duty over there at Maxwell. And so I would bring both of these handbooks to your attention. They're very well written, and I'm only able to go over a short glimpse of them, but I'll just read it here in the event that you are doing this while driving and you can't see it or something. But more rigorous quantitative risk management processes, including risk-informed decision making and an enhanced continuous risk management model, have only recently been developed for implementation as an integral part of systems engineering at NASA. While there will probably always be vigorous debate over the details of what comprises the best approach to managing risk, few will disagree that effective risk management is critical to program and project success and affordability. I think that in the age of people just going off their gut and everybody reviewing everything online, we start to fall into the trap of thinking like, oh, we know best and we can go off instincts and shoot from the hip. And that's one of the things that I think we're all probably pretty glad that NASA and SpaceX and all the other companies who work on these types of items, they don't shoot from the hip. They analyze everything very thoroughly because there's people's lives riding on the line who are both the astronauts who are on the exact missions, as well as all the support crew and all the people who they fly over as they leave our atmosphere and go into low Earth orbit or into cislunar orbit to the moon for the Artemis program. And so one of the things that I liked about this process versus some of the severity versus probability risks that I am going to show from an Air Force mindset is that it's all requirements based. And I think many times in the military, at least with flight planning, you're going to be doing a lot of flight planning risk analysis, and but you're not always going to be doing a lot of infrastructure or facility analysis. I know one thing that since we're self-insured, and my last job in the Air Force was at the Air Force Installation Mission Support Center, we were seeing incredible amounts of our facility management SRM budget getting eaten up by just regular hail damage. And so it was really unfortunate that we had to spend all that money on hail damage. And so we started to try to come up with different strategic enterprise sourcing or other initiatives to make sure that we evaluated that. And if you looked at it on the outside world, much like you would do personally on your car, you know certain things that are going to happen on your car, and when there are repairs needed, you pay for those. But when there's something that is so severe but has such a low probability, that is when insurance comes into play. And so if you think about that mindset, the NASA systems engineering is that word I used before, stochastic. It means many inputs, many outputs, and no clear linear approach of a way to look at them. NASA takes that complex system and they provide a flow chart for helping you analyze that. And one of the things that they use at NASA that I think you might be more familiar with if you are in a traditional project management or a construction management approach is a Monte Carlo analysis. And so I'm not going to go into the details of this chart here, but what I am going to talk about here for a second is I don't think that we do enough evaluation, especially on the construction side, which is obviously my background, and perhaps not enough on the infrastructure and system of systems approach that Dr. Chuck Wolfe is going to talk about. But if you're not familiar with the Monte Carlo analysis, let me just give you a really quick background of that. And the example that they use in the NASA manual that I referenced a second ago is different planetary science mission examples. And so the examples they use, even though it's about something with planetary science, I think you can probably all wrap your head around what those items are. They are a constrained budget, a constrained schedule, a possible contamination factor, which is probably the most science-based model that they talk about here. And then one other constraint that I'm having difficulty reading right now. But what a Monte Carlo analysis is if you have 4 different factors and you have different variants of what those are. So imagine 4 or 5 different project costs, 4 or 5 different project schedule durations that you're allowed to have, and then 4 or 5 different probabilities of, in this case, a contamination of a parts per million, you using the confidence intervals that you think that you have, so your certainty in your data, and this is where I'm not an actuary, but and it gets heavy quickly, but I think you can think about this just even in a simple Excel spreadsheet. You're providing different alternative analysis to see what is the most likely given the constraints that you know. And when you run the Monte Carlo part of that is just like as it sounds, like a James Bond movie or something like that. You're running the scenario over and over again, just like on a craps table. You have a 1 in 36 chance or a 1 in 38 chance of getting any of the 0, 00, or numbers on the red and black parts of a roulette wheel, or the different numbers. You got 1 in 36 odds of hitting a discrete roll of a dice in a craps game. Over time, there will be a distribution of the most likely scenario. And so the best data you can put into your scenarios, that's what you're going to get out. And if you think about Winter Storm Yuri, that's one of the types of things that we've seen is I think people need to widen their idea of what the probability is for these events, because we've had weather events that we have never seen before. And not going into causation or causal factors, I think that we can realize that we probably need to engineer, design, and construct more certainty, more resilience into our infrastructure and into our facilities because of the greater probability of high severity events. And so moving back over to something that Justin and I are definitely more comfortable with, is on the Air Force risk management side. You have different risk management levels, and most of the risk management in the Air Force is usually related to aviation and flying and ground mishaps, which makes sense. But the part that isn't always used on that high level of safety culture are the types of things that we have in our infrastructure. A lot of times we run things to fail, or we just have a worst first type approach. And it would be fantastic if people could work these sorts of strategic level initiatives into their day-to-day thought process or into how they analyze their decision on what to repair. And so beginning with something that might be of the most familiarity, and if you're not at least familiar with this, or if you only take away one thing from this talk, I would say definitely go look at the NASA area on risk management and systems engineering and systems thinking, and then also the Air Force risk management approaches, which this is the primary sample risk assessment matrix that you should really be doing all the time. So the x-axis is probability and its level of frequency, and then the y-axis in this situation is severity, so the effect of the hazard. And just as an overall question, I'll ask Justin, where do you think before Winter Storm Yuri, which quadrant or which part of this chart do you think that people would have placed a multi-day freeze in the state of Texas for all 254 counties? What do you think, Justin?
Well, that's an easy answer, Dr. Suermann. Probably fall in the last column, very rarely, maybe within the seldom column.
Yeah, definitely for probability. But then, and that's where sometimes I think you can have an approach where you convince yourself of the answer that, and you have to make sure you keep these, as while they're obviously not mutually exclusive, you do need to keep them completely separate, because I think people would think that since the probability is an E, it's so rare, they probably would think, well, it wouldn't be that catastrophic. But it most certainly, even a 1 day could have been catastrophic. It's certainly critical. But the effects of Winter Storm Yuri, obviously with hundreds of people dying directly attributable to that, show the ethical responsibility that we have as engineers and as constructors to make sure that we address this level of severity and probability. So with that, I'll hand it back over to I think to Justin on this part. It might be Chuck, I can't remember, but primarily just to wrap up my part, I would encourage everyone to look at the NASA documents. You can get a lot from them. I only showed you just a glimpse of them, but they really stepped through. That's the good part about it being 286 pages. So they really stepped through a process that I think if you're looking for some kind of a partnership for your project teams, it would be great to sort of tabletop some scenarios that you're analyzing on cost or schedule or different constraints, and doing an analysis on that. And I'd also be remiss if I didn't do a plug that Texas A&M has continuing and professional education programs or other consultants that you can access through engineering or through architecture, construction science program to help you with these sorts of project management analyses. So over to you.
All right, thank you, Dr. Suermann. Transitioning into the expeditionary mindset, I think that's a topic or idea that we can all relate to. Again, being associated with the water industry or military ties, we get comfortable in the military within our stateside jobs and assignments, I believe. But there's always, our real job is in an expeditionary environment. And that's what we train for. That's what we prepare for. And so when those thoughts and ideas are applied to the water industry, or really any industry, that kind of sets up that tone and mentality of thinking and how to prepare for storms such as Yuri and other major natural disasters that could impact the industry. And so when we think of expeditionary mindset and performing in that type of environment, we think of terms like being ready and reliable. And I'll relate some of this to healthcare primarily because that's my background. That's what I do in the Air Force, is healthcare administration and construction. And so, being ready and reliable, having ready and reliable healthcare, having ready and reliable members and family members to serve and meet the downrange mission. And that really involves having a unified culture, everyone being on the same page. Anywhere you go in the military or anywhere I'm assigned, the process, the concept of operations and the procedures and training, it's the same. And so when we go downrange, no matter what the event, natural disaster may be, we have a process and idea on how to work through that. And that's really what enables us to be successful and have the best Air Force in the world. High reliability practice. We want to ensure that what we're doing in healthcare and also as we look at the water industry, it's reliable. There's assurance out there, and to have innovative solutions to back that up. And so as we go through training and so forth and different exercises, we take those lessons learned and create solutions collectively, go through additional training, and then repeat that process over again. There also needs to be a functional application applied. It needs to make sense, similar to the risk assessment or risk management matrix that Dr. Suermann covered previously. We kind of look at that like a Pareto chart. And so our solutions and so forth that we set in place, we want to focus on the most severe or most common occurring risks first, as those addressing those risks would have the most impact. And then also an integrated system, coordinating with one another. And that's really when you get the best ideas, best communication between different teams. And again, as mentioned previously, with the expeditionary mindset, readiness is really a strong aspect of that. And being able to provide critical services during all hazards, both in the water industry and healthcare and in construction, and engaging in that continuous cycle. And so you can kind of see the preparedness cycle outlined here. But once it's critical that you continuously relook at this, because there's always lessons learned, there's new events, new storms. We can never really be prepared for all situations. We can only trust the processes and solutions that we have. And so continuously familiarizing ourselves with those processes and solutions, that's how we will be able to better perform when the events do arise, such as Yuri. And then there's a lot of tools out there. For example, a training and exercise plan specifically for the water industry found on the EPA website. And so this is a good tool that different companies may choose to implement to perform monthly or quarterly exercises to better prepare for storms such as Yuri. And it kind of guides the team or company to outline their priorities and build a line of communications with associated departments or other government entities. That way, when events do arise, you've got a network built to resolve those issues. And with that, that concludes my portion, and I will turn it over to Dr. Chuck Wolfe to cover the water industry application.
Okay. Thanks, Justin. So we've got another poll for you that hopefully Dan's going to launch for us. Thank you. And this is really just sort of to give us a little perspective on your familiarity with public water systems and how they perform and what they need from a performance perspective. So while we're working on that, let's see. So we have some folks that are not familiar with that at all. That's fine. I actually was involved in the city when I was in Arizona, and I got done with a presentation about the water and wastewater system. And one of the folks in the room said, "So let me make sure I got this right. When I turn on the faucet, the water comes out. When I flush the toilet, the bad water goes away." I said, "Yep." He goes, "I know everything I need to know." So we can work with any of this stuff. What I would say on this from a high level perspective, so it looks like we have another pretty much normal distribution, which is good. What I'd say when we're thinking about the water system and really any foundational infrastructure, you really shouldn't know it's there, right? You shouldn't know what's driving it, what the requirements for it are. As citizens, we do want to turn on the water faucet and good, safe, clean water comes out. And when we wash our clothes or wash our bodies or go to the bathroom, we want all that stuff to go away somewhere, and we don't have to think about that either. Same thing as you want your phones to work, you want your computer to work, everything else. So those of us that work in the water industry think about this all the time. The penalties for water directors that have water system violations or water system disruptions, or even boil water notices that are not extraordinary, are pretty punitive usually. There is a very, very low threshold for where the situation becomes very bad for the folks that are responsible for these systems. So as a designer, which is where I've spent most of my career, but I have been also an owner, been on the owner side, both of the water supply authority as well as a municipality. We think about this all the time, and we tend to think about it within some questions. So the first question that most folks in the industry will ask is, well, how safe and reliable is the water supply? And we tend to think about this within the context of, do we have the appropriate volumes of water that we can access? Can we get those volumes treated, and can we get them out to the community in a safe way? Can we collect those wastewater flows and get them back into the environment in a safe way so that folks that are downstream have the water supply that they're supposed to have? We don't tend to think about it within the or the micro environments that you have when you have a situation like Winter Storm Yuri. So that brings us to the next question, which is really how should we define water supply reliability? And then what drivers should impact the reliability of water supplies? And what not only should they, but what drivers actually do impact the reliability of water supplies? So it's interesting to me from a water professional perspective that the tools and the skills that Dr. Suermann and Major Baird are talking about can absolutely be applied to what we do in public systems for drinking water as well as for wastewater treatment and wastewater and environmental protection. But we do need to sort of expand the way we look at it. And this is where that expeditionary mindset that you are out in a place where you cannot have a failure or it's going to cause immediate death is something that we don't think that way typically from a water supply perspective. What we tend to think about, and maybe what we should do from an expeditionary perspective, is add the final phrase here. So we always think about water supply reliability of having water supply available when it's needed at an appropriate quality for what its use needs to be. It's not the at all times. And in saying this, I am not throwing anybody under the bus that works in this field. There are a lot of things that impact our ability to add at all times to this particular equation. There is significant restrictions in funding, particularly in the public sector. Water is in a lot of respects. It's such a personal thing for humans. We're mostly made of water. We need water. That there are absolute rights, and endowments types discussions when you talk about water. So funding is always a challenge. Being able to staff to be able to do this is always a challenge. But we tend to fall back into a mindset of, well, what can we do with what we have, as opposed to potentially stretching that mindset and pushing a little bit further to, well, what else could we do, or what else could we consider that potentially could be that impact? So currently, how we do the water supply availability and appropriate quality is we build a lot of redundancy into the actual systems that you're working with to be able to deliver safe drinking water and safe wastewater services. So we'll have redundant pumps, we'll have redundant subsystems, we'll have other approaches. And if we think about it from an expeditionary mindset, we sort of need to move beyond redundancy, because redundancy is something you control at a single location, but it's not what can possibly impact you further on down the road. So, as I mentioned, redundancy helps, but it's not enough in and of itself. So some of the redundancy features that we put into a lot of facilities that were compromised during Winter Storm Yuri. So most water treatment plants and wastewater treatment plants will actually have a completely independent secondary electrical feed. So if you were to lose a substation, or if you were to lose a power line on the way to the plant, you could keep the plant powered. And this is a wonderful piece of redundancy. The problem is it doesn't work when the entire generating capacity goes offline, or where we have to shut things down so that we can protect the generating capacity. Like I mentioned earlier, we were 277 seconds away from having a complete and total power grid failure, which would have taken weeks to reboot from and get things back up and running to even a somewhat normal level. And unfortunately, water and wastewater plants can't always be located on a leg of the system that has to be up at all times, like we try to do with medical facilities. So one of the things we do to protect against this potential issue is we have generators at most of these facilities. Of course, they only work if you have fuel for them. So for all of you that live in the north and think that us Texans are sort of funny because we don't have to deal with a freeze, you're absolutely correct. Driving around College Station, Texas on a frozen day, I just don't do it anymore, because we've got a bunch of 18 to 23-year-olds that don't know how to drive on perfect roads, and now they're just bouncing off of everything. But if you have a diesel vehicle without a block heater in it, you get to enjoy the beauty of diesel at really low temperatures when it doesn't flow. So we have two types of generators that tend to use in the water industry: diesel generators and natural gas generators. It was so cold that the diesel generators were having trouble firing up in most locations, although we were able to get some of them going in some of the southern cities. And of course, the natural gas system was one of the major systems throughout the state that failed, that caused the power generation issues. So natural gas wasn't moving around the state either. So these utilities that we depend upon, that we usually can depend upon, were just not available. One of the other things we do in water systems is we tend to have closed loop pressure systems, so that you don't have to feed from one point. You get better water quality because of this. You get better pressure differentiation. You also get some built-in redundancy, but it only works if the lines are working and they're secure and the valves are operable. So some of the photos you've seen sprinkled throughout this presentation were photos that some of our team took as they went around the Houston area during the event, helping the city of Houston document line breaks, valve failures, other issues that were happening throughout the system that actually caused pressure losses so that the system couldn't function correctly. And it was simply because it was too cold. And then, of course, we also have excess treatment capacity, but that can only work if the systems are functional. So there's these upstream systems we talked about: electrical power, other things that impact treatment capacity. But in water treatment plants, we tend to use polymers in order to help the water clear up when we put them into filter systems. At the temperatures we were operating at, actually, one of my engineers is a bit of a process guru. He went and lived at one of the plants for a few days because they had to keep changing the polymer blend in order to keep the plant running correctly. They were able to, but it wasn't as simple as there's a backup system or something else. So even excess treatment capacity was put at risk because of the cold. So how can we work on this to try to make things a little bit more expeditionary mindset? So one of the best ways to do this is to really dive in from a systems perspective and from risk management perspective, and dive deep into root cause analyses. But make sure from a systems perspective you're understanding all the supply chain impacts to the system that you're operating. So questions such as, what will impact the generating capabilities? I've got natural gas. What could impact natural gas speed? I've got diesel. How can I make sure that the diesel that I have in the unit is going to work for the operation when I need it? And if I need more diesel, how do I know I can get it when I need it? Those kinds of things. How can systems be prepared to operate under all conditions? How can we have this expeditionary mindset on the site, not just the most likely ones? And I'll go back to the risk equation or that risk chart that Dr. Suermann put up. I would argue that it was rare to not going to happen, and most people in the state, because I certainly was in this boat, felt like it couldn't get cold enough to create a problem for our power grid. It couldn't happen, which is quite frankly exactly why it did happen. So how can we stretch our thought process a little bit and think about different eventualities that could cause a problem? So for those of you that are working on water and wastewater systems, but those of you also that are working on plants or bases or other types of facilities, we're using a lot of asset management and maintenance program procedures now in the industry. So we sort of have this CapEx, OpEx management model. And I think that that's a framework that you can build in these systems thinking. You can build in some of these advanced risk calculations, and start thinking about these root causes. Build that into your asset management and your maintenance program, and think about how you can move from individual system criticality to the components that impact your full system functionality, so you can maintain functionality at all times. So I mentioned I was in the public sector. I ended up being the chief technical officer for an authority, and we had dams. And when we have dams and you start looking at the number of people that can pass away if you have a dam failure, it really does humble you to look at total full system functionality. When we would do those maintenance program, asset management programs, it was not just the one individual system's criticality to the next system, but we would actually draw that all the way out to the ultimate system. We can do that for drinking water systems. We can do that for wastewater systems as well. The key is we have to sort of dig deep. And we have to sort of get foundational answers to these kinds of questions. If you do that, I think it's going to help your system planning and performance during any crisis that you may come up with. So we wanted to leave you with a quote from Thomas Kuhn. So it says, very often successful scientists must simultaneously demonstrate the traits of both traditionalist and the iconoclast. And certainly what we're talking about here, there's a lot of stuff we do day in and day out to protect operating systems. That's traditional. But the iconoclastic piece of this is sort of thinking well beyond the normal sphere of what we do, really pushing ourselves. And that expeditionary mindset sort of fits in this concept of how could we make this bulletproof at all times, as if every single potential impact is a potential deadly impact, and then try to build that into our planning and financial management approaches for utilities, bases, other assets that you may be managing.
Hey, Dr. Wolfe, Josh Cathy, I hope I said his name correctly, asked a good question in the Q&A. He said, how has the Yuri event changed the risk models for Texas? Have they begun to implement different controls in their power and water infrastructure at this point to mitigate a 100+ year weather impact in the future? Because I think he's obviously saying, just like you said, I mean, it'd be great to have every eventuality covered, but that would be cost prohibitive. So have they modified their risk models, or what can you tell us about that?
Yeah, so a lot of the utilities that were directly impacted have started to look at, because they had all their stuff in order for the most part. They've started to look at where things impacted that they couldn't control. The state has taken it became the focus of the legislative session, because it just happened that we were just kicking off the legislative session last year when this freeze happened. So the state has taken a deeper look at power system grid reliability. What were the issues? What were the failures? How do we winterize certain facilities that weren't winterized? But I will say we're still a long way. This is Chuck talking. We're still a long way as a state from being in a place where I would say we've got those controls in place to set things up. There was a bill passed in the last legislation. It's called Senate Bill 3, and it does require every utility in the state to do the kind of analyses that we're talking about, where they need to think about all the potential things that would impact them and what their emergency response program would be. The southeastern part of the state, Houston, the area close to the coast, already had these requirements because of all the hurricanes, but now we've sort of pushed it out the rest of the state. So that's a good step. I'd say we still need, honestly, another year or two before I would be comfortable saying that we've started implementing different controls to be able to do this.
Thank you, Chuck. Good answer to a definite salient question by Josh.
Yep.
Right,
so you can put Q&A into the Q&A tab on here. You can put it in the chat as well, but the Q&A makes it a little bit easier to answer.
Yeah, so another one here is understand about expanding thinking to encompass truly unexpected threats, but how do you balance that against the cost issues? Yes, I'll take a shot at that, and then others can chime in if they want to. I think fundamentally, and actually we had one of our, he's now a PhD student, but he was one of our master's students, actually looked at this for his master's thesis. And it's a matter of where you start your thought process. And if you start your thought process on the monetary side of things, you generally end up at a place that is going to cover less eventualities. So I think what we're arguing is we know there are cost issues. There are priorities that you have to pay for as a water utility operator, and there's situations that you don't have to pay for. You don't have to pay for electrical system reliability, but you can certainly advocate for it because you are, generally speaking, one of the biggest customers that most power suppliers have. So the argument here would be work from the perspective of what is the totality of the threats that could impact us, what are potential solutions that could address those, and then what are our cost constraints. And there's ways with fee calculations, other things that you may be able to actually work on on those cost issues too.
There's another question in there, but I'm going to jump on to what you said there. Is I liked what you said is move beyond redundancy, because that's one of the things that in my work with NASA and then just in my own personal entertainment life, listening to astronaut books, like How to Think Like an Astronaut, for almost every eventuality, they have the inputs and they have a boldface or a checklist of the types of things that you can do to incorporate other systems that would then at least benefit you to the level that you have. So I'll ask you to answer this question after we answer Keith Parker's question, because I like that people are putting questions in the Q&A. But so after Keith's question, could you answer, do we have ways that limit redundancy but offer existing switching where you could, I guess that's partly what the rolling brownouts did. But so that's the first question that maybe you can answer after Keith's, but I'll read Keith's for everybody. I'm in Dallas and was without power and water for 7 days. That's terrible, Keith. I'm sorry. Governor Abbott says, though, that the infrastructure is the best it's ever been, but doesn't go so far as saying if another storm like last year, it would hold. So I think you might have answered, but what's your assessment of Texas being ready?
I don't think we're there yet. So, and it's not that we're not trying. There are some challenges. There's some benefits to having a fully dedicated and independent power grid. By the way, there's a lot of control that Texas has on its rate structure and the way it does things. But the challenge with it is a gigantic infrastructure to try to winterize, and it's expensive to winterize because we don't have that event very often. It is definitely a rare event. It could happen more often, but it's definitely a rare event. Even if you want to say it's 100 year, it's a 1% chance of occurrence in any given year. So we're doing some work once again through A&M with the United Nations Disaster Recovery Office, and they're actually very interested in Winter Storm Yuri for the exact question that Keith is asking, because Texas is basically the size of many countries. The economy is the size of many countries. No other place in the United States do you have this situation where you have this microcosm of a single grid. The rest of it's spread across the country. So I think we're getting closer, but it's a massive piece of infrastructure to try to winterize. So I honestly heard the same quote from Governor Abbott, and I sort of compartmentalized it a little bit as just political speech as opposed to other things. I know a lot of utility operators around the state, a lot of water suppliers around the state that we work for in my professional life are very concerned about how they can ensure that they're getting the power they need to operate their systems. So back to Dr. Suermann, back to your question. There's been discussion about how can we redefine the grid? How can we reconfigure the grid? How can we, as smart grids and microgrids, start to develop throughout the state, find ways to protect all critical infrastructure the way we tend to protect hospitals? So if Keith, you just didn't live close enough to a hospital, right? Type of thing. I mean, it was sort of the going joke. If you lived close to a hospital, you didn't lose power, you didn't lose water, you didn't lose anything. But we need to look at the other critical infrastructure too. So this is a community planning level discussion in some cases, as well as just what a particular utility may have to look at. But I think we're a ways away from being able to winterize the structure. Winterize the electrical grid. It's going to take a massive investment.
Yeah, it was interesting to me. I moved here from Colorado, and I just had a certain phase of football season that I expect to winterize my sprinklers. And so when we got to that part of the year, I called around to, this is pre-Yuri, this is a few years before that, I called around to sprinkler guys, and they're like, no, sir, we don't waterize the sprinkler or winterize the sprinklers here. And I was like, oh, okay, they're using that tone that I'm an idiot, but maybe not. So
yeah, I had my sprinkler system break in College Station in 2014, 2015. We had the hard freeze because the backflow preventer had to be above ground. So it was in the wind and it froze. So I winterized it myself by putting it below ground.
Yeah, we had something similar during Yuri. Ours, luckily, it wasn't too severe, but and that was with having the insulation on it. But Keith, tells us all now that he is now going to move near a hospital. So thanks for making well-informed decisions, Keith.
Yes, exactly. There are benefits to it. In all seriousness, that we have identified infrastructures that absolutely have to have power and water at all times. So we are doing this as communities in some respects. Expeditionary thinking. Just we need to, and quite frankly, I think to some extent this is, as customers, we need to be able to empower the leaders of our public utilities to be able to do it, because there are really smart people in these organizations. So it's not a matter of can they do it or not do it, but sometimes they know straight up they're never going to have the money for certain things, so they work with what they can.
Well, Dan, we've got a 5-minute warning here. Do you have any other announcements for us, or can we take one more question?
Yeah, sure. Well, I wanted to ask, and this kind of dovetails in, what kind of advice or approach would you guys recommend for somebody who wanted to work with a community on like a potential analysis?
I'll probably throw that to Dr. Wolfe. I mean, we have our areas with we have planning within landscape architecture, urban planning. But what would you say, Chuck?
Yeah, so it's interesting. It really depends upon where you are in the world. This is as much of a cultural thing around help as it is anything else. So we get more engagement in Texas working through academic institutions than we do even sometimes working through consulting agencies. So like some of the research that I'm doing right now at A&M, we've got Freese plugged into it in some respects. And, people will say, well, can we just run this through A&M? And it's like, well, we can't. Dr. Suermann knows this. There's all kinds of issues that come up sometimes. So, so I think one way to do it is think about the parties that could actually be able to have standing in the discussion. So in some areas that's an academic institution, some areas it's major industry, major industries that are there if you're really economic development driven. And in other areas it's concerned citizens. And I think concerned citizen side of this fits into the size of the community you're working with. So I mentioned I worked with the community when we were in Arizona. I was actually on the council for a while, but before I got on the council, I was on a water wastewater advisory committee. We had 35,000 residents. So it was easy for citizens to be plugged in and engaged in that respect. City of Dallas, City of Houston, New York, Columbus, Ohio, enter major city here, Denver. It's going to be a lot harder from a systems perspective. But if you're interested in promoting and in pushing this kind of a thing, if you know what the touch points are, the people that actually have the voice to be able to say, hey, let's work on solving this, that's probably the best way to go. But it's going to be different depending upon every community you go to.
That's what I was going to say. I like to piggyback is number one, be an informed citizen. Number two, vote with the information that you have as an informed citizen. Participate in town halls. But then I do think, much like the space industry looks to commercial partners, we had a consultation with HEB, which if you're from Texas, that's probably like your Publix or your Piggly Wiggly or Harris Teeter or Winn-Dixie or whatever you like for grocery stores. But people are zealot fanatics about HEB here, and we found out a lot about how HEB operates. And much like another thing you could look up is the Waffle House Index, because Waffle Houses pride themselves on being open as a place of refuge, and they oftentimes don't even have locks on the doors because they're open 24 hours. HEB likes to be the absolute first thing open after a disaster or an event. And I was surprised with their portfolio. They have a lot of shipping and their own power and their own distribution systems that rival water and power and data systems. It was amazing to me. But HEB reinvested in itself very well, and those I'm excited that I think that Governor Abbott and the other politicians who when they are trying to solve this, they lean on the people who do this for a living, and that's companies that are great like HEB. So with that, we're wrapping the end of our time, so I'll hand it back over to Dan.
All right. So I just wanted to also mention that the handout section, the slide deck and the PDH certificates are available to download if you want to get some more information, want to take a closer look at some of the standards that Dr. Suermann mentioned in his section, or read through some of the graphs and tables presented today, download the slide deck, flip through it, and check it out. So with that, thank you, Major Baird, Dr. Suermann, and Dr. Wolfe for your time and for your presentation today. Thank you to all of the attendees for taking the time to listen in. So if you're interested in submitting an article to the Military Engineer, you can visit our website that has our editorial calendar and our guidelines. We're currently open to proposals for our July-August issue, which coincidentally is going to focus on water planning and management. So if you've got a project or some other insights that you'd like to share with the engineering community here on water planning and management, feel free to send us a proposal. We'd be happy to take a look over it. Those are all going to be due on March 15th. So just another reminder, download your PDH certificates and the slide deck. And so then on behalf of SAME, the Military Engineer, and our featured presenters, thank you all for joining us today, and hope you all have a great rest of your day.
Thank
you.
Thank you.